so this video is going to be covering acoustic admittance testing, which will include tympanometry, acoustic reflexes, and then acoustic decay. So I want to start by getting you familiar with our equipment. This is our main middle ear analyzer that we have in the lab. It's our GSI 33. The power switch is here. Usually when you flip it on, it takes a few minutes to initialize, so I already had it set up for us. It automatically defaults to our tympanometry setting, and if we want to change the setting, which we will do later on, acoustic reflex would be there, and then this one labeled special, that's what we use for acoustic decay. So we can start talking about other parts of the equipment. So this is our shoulder box there. It has two weights coming off of it that we use to keep it on the shoulder. It has three different tubes coming off of it. One of the tubes is a speaker to produce the different tones. Another is the pressure pump, and then the third would be the microphone, which would detect the middle ear's response. All three tubes go to a single probe tip. So that would be the probe, and then you can put on different tips. We have different colors and different sizes of those. And you just always make sure that when you put it on, it goes all the way down. We don't want anything leaking out. The shoulder box has two different lights on it. It's flashing green right now, which means that it's on and ready to go. If it flashes yellow at you, that means that you have a leak, or that maybe you have the probe up against the canal wall and some of the air is leaking out. It just means that it's not a good seal. So you would have to try out the different size tips and get one that gives you a better seal. So before admittance testing, you'll need to do otoscopy, and then obviously take the case history, and then start by giving instructions before you put anything in their ear. So you could tell the patient that they're going to be hearing low tones. They're going to feel a change in pressure, kind of like going up and down in an airplane very fast. All they need to do is stay still, quiet, and try not to swallow or move or anything like that. So to insert the probe, what we do is we pull the pin up and back, and then we use kind of like a scooping motion, kind of like this, into the entrance of the ear canal, and then until we have a good seal, and if it's in there properly, it should feel secure and it shouldn't move with any minor like head movements or head shakes. So for tympanometry, so the setting we're at right now, it tells us about how well the eardrum moves as a function of pressure. It gives us, our measurement will give us three things. It gives us ear canal volume, peak pressure, and then compliance, otherwise known as static admittance. We'll be testing at 226 hertz because we're all adults, but if we were testing pediatrics or under the age of 6 months, we would be using 1000 hertz. So when we go to test, we click this start arrow with the arrow to the left, and that means that it's going to sweep in pressures to the left. So we'll be going from 200 positive decapascals to negative 400 decapascals. And that pressure is what's being applied to the ear. And then along the y-axis, what we're measuring is compliance or admittance in milliliters. And then it'll be plotted on that graph. So I'm going to go ahead and now put this probe into my left ear and try to give you a measurement. So I'm doing that scooping motion, pulling my pin up and back. Trying to get a good seal. Let's try to run a test. Okay. And then I push stop to stop, and I'm going to pull it out of my ear now. So here is my measurement. And you're going to notice three things. So three outputs are right over here. We have ear canal volume, which was 1.4 milliliters. And if you remember, our normal range is between 1 and 2 milliliters, so that's within normal range. Then I have a peak pressure of 5. We want anything that's going to be close to 0, because 0 is atmospheric pressure. So the range that we find acceptable is anywhere from positive 50 to negative 100 decapascals, so that's well within normal range. And then for compliance or static admittance, we have 1.1 milliliters. And if you remember, compliance should be anywhere from 0.3 to 1.5, so that's also within normal range. So since all three are within normal range, what Jurger type is it? Type A. Good job. So to retest and to clear it, we click clear here, and then we can click clear all with that function key. Then we can do another test. All right, those are the basics. We'll cover it more in class. See you then.